special meaning in C and C++ where it's used to specify no value for function returns and function parameters. Let's go ahead and make a working copy of voidtype.cpp. I'll paste it here into the working project and open it up. Here on line 5, we have a function declaration, and this function returns a void type and takes a void type for its argument. And we have the definition of it down here. And you'll notice that it doesn't actually return anything, and it doesn't actually have an argument. So this is the primary meaning of the void type. It's not used for variables. You can't create a variable of void type. You can't assign any value to it. You can't take any value from it. And that's actually what it means. It's really only used for function parameters and function returns. So if we save this and run it, you notice it has the void type.c, and then it runs the function and it says this is func. So that's the void type. There's another special usage of the void type, and this is for void pointers. We'll go ahead and we'll close this, and we'll delete it from the working project and run clean. And then we're going to open voidpointer.c. We'll get to voidpointer.cpp in a few minutes. And we're going to copy that and paste it into our project here and double click on it. I'm going to go ahead and maximize this so that you can see it. Here we have, again, a function declaration. And this function returns a pointer to void, and it takes a pointer to void as its argument. And here's the definition here. You pass it this pointer, and it returns the pointer, and they both have this void type. So what the void pointer means in C and in C++, although it's a little more complicated in C++, we'll get to that in a minute. But what the void pointer means in C is that this is a pointer, and I don't know and I don't care what type it is. And so you see here that we do a character pointer with a string, and we pass that character pointer into the void pointer function. And the void pointer then returns that same pointer, and it returns it as an int type. And then we're going to print out the 8 hexadecimal digits of what is pointed at by this void pointer. So it's actually going to print out this string, but in hexadecimal. So let's go ahead and we'll bring this back down to size, and we'll compile and run it, and you see 34, 33, 32, 31, and that's because the byte order of the Intel processor is backwards. But what we've got there is 1, 2, 3, 4. So in hexadecimal, that would be 31, 32, 33, and 34, and that's what's being printed out. So again, looking at this, we have a character pointer. We pass that character pointer into the function, and then the function takes that character pointer as a void pointer and returns it also as a void pointer. And then we take it back from the function, and we are assigning it to an integer pointer and then printing it out as a hexadecimal value of that integer. And so we're taking that character pointer and we're using it as an int pointer all through this void pointer function. So void pointers are basically a polymorphic pointer. Now we're going to look at how this works in C++. C++ is a lot stricter about how this works. So I'm going to go ahead and I'm going to delete this and run clean. And then we're going to take voidpointer.cpp and paste it into our working and open it up. And you'll see the difference here is really just about how strict it is. When I pass that character pointer into the function, I actually have to cast it as a void pointer. And when I take the integer pointer back from the function, I actually have to cast it as an integer pointer. Let's go ahead and compile and run this. And you see it compiles and runs and has exactly the same result. But if I were to take these casts and remove them and make it look just like our C version, you notice right away I get this little bug symbol, and it says invalid arguments. Candidates are void pointers. And if I try to compile this, I get all kinds of errors. I get an error up here saying that I initialized the argument 1 wrong, and I get these errors here. Invalid conversion from void pointer to int pointer, invalid arguments, conversion from const void pointer to void pointer. So all of these errors are mitigated by simply casting. And so when I save this and compile it, all those errors go away. So C++ is a little bit more strict about how you pass around these types. And that's actually a good thing. It helps to prevent you from making some costly mistakes. And the use of void pointers in C is actually a place where it's really easy to make some very costly mistakes and have a lot of debugging on your hands while you're trying to figure out, why this thing doesn't look the way that it's supposed to look. So while void is syntactically a type, it's only used in special circumstances. Its value as a return type or as a parameter type is to enforce a rule preventing use where a value would be expected. And its meaning as a void pointer is different yet again as a polymorphic typeless pointer. So let's go ahead and